Welcome to Statistic 1, Chapter 7, the Normal Distribution, topic, Z-score. From our previous video, I mentioned about the normal distribution curve. So what I have here is something different, called the standard normal distribution curve. This one is different because it is standard. So any normal distribution can be converted into the standard normal distribution. So this one is the standard one that every single normal distribution can be converted to. So the first point, this one is different from the other ones. The standard deviation normal distribution curve always have the means equal to 0. It means equal to 0, and it in the middle here. This one here. The second thing we want to mention is that this one is drawn not on a normal scale that we use. It uses another scale which is called the Z-score. The Z-score scale. Z-score. From the Z-score, we can know the position of our values where is that in the normal distribution curve. Like, let me take an example. Let me take this value. X here is a variable that we can use. We can take on any value we want. The formula for Z-score is that Z equal to X minus U over minus the mean over standard deviation. For this case, X equal to U plus standard deviation, the mean. So the Z-score will be equal to mean plus standard deviation minus the mean according to the formula over the standard deviation, which is equal to standard deviation over standard deviation equal to 1. So its position is in here. The Z-score is in here. Let me take another values. When X equal to mean minus 2 standard deviation, so the Z-score be U minus 2 standard deviation minus U over standard deviation equal to minus 2. So its positions in here. So from this one, we know that from the Z-score, because mean is 0, means always 0. If we have something Z-score of us is minus 2 minus 3, so it is the distance from X, from the X we have the Z-score equal to minus 2.3, is that distance from this one, this point to this point. We know that the distance from here to here is minus 2.3 standard deviation. This one might sound really abstract for you guys to understand what is exactly the score, which is a scale. This is a scale. So you understand it more when you're moving to working on problem of normal distribution. So we will stop here and move to the next part. I just want to give you some basic concept of what I'm doing. Looking into this curve, you might wonder, is there any relationship between this curve and statistic? Like failure, success, probabilities of something. And now here's the magic between this curve and the statistic. I have a function called the phi function of z. When we have the value of z, we use this function, the phi function of z, to find the areas of the normal distribution curve to the left of the value z. For example, when I have the numbers of z equal to 1, substitute into this function, I can find this area, the shaded area here, shaded here. You can find the area of this part, the one to the left, the value z. the thing that you have to remember, the phi of z only give the area to the left of that value, not to the right. Because we see here, and as fast as we know, the total area of this one is always equal to 1. And the area given by z represent the probabilities of a value which is smaller than z. Here, if you find this one, it might be 0.623. I don't know what the exact number. I just take a random numbers that I think of in my mind right now. Here, when z equal to 1, the areas of this one is 0.623. So the p of something with z smaller than 1 equal to 0.623. I don't know the exact number, but I just choose the random numbers in my head, over 1 equal to 0.623. The area gives the probabilities of a value is smaller than value z. But here, the equation is really complicated and requires time to you have to put numbers in there, you have to use your calculators and calculate a very hard to remember equation like this. But we have a way to convert your z-score into probability directly with the CIE board will provide you in exam. We call the z-score table, and now we'll learn how to use it. This is how a z-score table look like, and I will work with you in a moment to help you guys to use the table effectively. You might think that with a z-score table and work out the probabilities of x z-score really quick and go through your exam really fast. But one sad thing is that I don't know what is the reason. Maybe the CIE board want to test you more on your ability, so they only provide you the probability of z-score, which is from zeros up to 2.9. They do not provide you the z-score of the one which is smaller than zeros. So now, but they do provide you a formula to find the probabilities of the z-score which is smaller than zeros. Now we will find out. Now you want to find the probability or the area of a z-score which is, let me take a random one, here, minus 1.7. Here you want to find this area or also the probabilities of a z-score which is smaller than minus 1.7. You want to find this area, but you don't know how to find it because they do not provide you this number in the z-score table. But you have to remember that, think back about the probabilities of standard normal distribution curve. Normal distribution curve is symmetrical. Now, because it is symmetrical, let me take 1.7 in here. 1.7. This area. Because the line, because the normal curve is symmetrical, so this area, the red areas, is equal to the areas of the blue ones here. These two are the same, but from the z-score table, you can find this area. I will use another color. From the z-score, you can find this area here to the end. But this one, this part, add up to here equal to 1. Add up to 1. And then you want to find this area. So this area will be equal to the phi of negative z equal to negative z means that minus 1.7 equal to 1. The total area of the curve minus this one, the one with green color here, minus this one. here the phi of z, which is provided in the z-score table. So it's how you can find probabilities or the areas for the negative value of z. Because the table was too long, so now I just take a part of it and instruct you how to use the z-score table. So using this one, we can have either two ways, either converting the z-score into the probability, or we have the probability and we want to convert them back to z-score. First, the first one is converting the z-score into probability. Z-score to probability. When we convert from z-score to probabilities, our main focus on three columns. The first column, which is in here, the second main columns from 0 to 9, and the third columns from 1 to 9 and what at end. So for the first column, it gives it the accuracy for 1 decimal place. The second column gives it the accuracy for the second decimal place, and the third one gives it the accuracy for the third decimal place. Let's take an example. If my z-score equals 0.2, so here my 0.2 here, and we look at our second decimal place, which is 0 in here, because we the third decimal place is also 0, so we don't have to add anything, so we check its values in here. So phi of z, you have to write down like this one, equal to 0.5793. For the next example, I would take a number like this. The z-score, I want to find the z-score of 0.17. Look at here, 0.1, so we'll work with this line from here to here, and the phi of 0.17 equal to, first we consider the first decimal place, which is 0.1, and then we look at the second decimal place, which is 7. So our probability will be this one, equal to 0.5675. It's the probability for the second decimal place. Now we will look at a number which is Now we look at a number at 3 decimal place. Z equal to 0.354. Let's take a look. First, my first decimal place is 0.3, which is here, this line. The next decimal place is 5, so I have this number here. I have 0.6368. Because my last decimal place is 4, look at here, 4 for this line, 0.3. So this one, I have to add 15 to the two last number. So it means that when I have to add 15 to the two last number, it means I have to add 0.0015 to the two last number. So my value is that 0.6368 plus 0.0015 equal to 0.6383. Is how I can find a value. From the table, we can also convert from the probability into z-score. Probability into z-score. Let me take an example. When I have a probability equal to 0.61 79. The easiest way, look at the hole here. It will start with a 6, will be something around here. 6, not 5. Start with 6 1. 6 1, look at 6 1. Here I have 6 1, 6 1 here. And I have a number here. We see exactly 0.6179. So I can say that my z-score equal to 0.3. Another example, when I have a probabilities which is equal to 0.5239. Now look at 5. I have 5, which is around here. I have a 2, and 39. So it is exactly 0.06 right from here. So my z-score is 0.06. This one in the second decimal place. Please remember that. We do not add 6 to here 0.6 or something. Just the second decimal place. I have a probability of 0.6076. Look around, 60 where 6 zeros on there, because it is greater than this one and smaller than this one, so it will be in this range, in here, in this interval. And we look at here, because 76 minus 64 equal to 12. Look at here. We have the 12 here. So when 0.6064 at the 12 will have this probability. So we'll get our z-score equal to this line where 0.2, 0.2, and we add this number to this one. So the second decimal place is 7, and we add 3 to this one. We add, when the third decimal place is 3, we add 12 to this one. So our third decimal place is this one. That's how we can find a z-score from these probabilities. I would like to have my last example for this one. And this is my last example. P equal to 0.6827. Now look at 68. Where is 68? 68 here, around here. Because I know that it's in between here. It's in between here because it's greater than this one and smaller than this one. Now take a look. 6827 minus 6808 equal to 19. Is there a 19 here? No, I don't have 19 on this one. This one I have 12, exactly 12. Here I have 19. I have no exact numbers in here, but I take a look. It will be in between this one. So first I can write the score of the two first decimal place equal to 0. This line 4. The first decimal place is 4. This one up to 19 to get this one. So the second decimal place is 7. But I don't know whether it's a 5 or 6 for the last. But I can see that 19 is closer to 18 than 22. So when this round up to the next previous decimal place, it will be round down, not round up. It will be round down to this one. So I can take this number 0. The last number will be 5 because it round down to 18 because it's closer to 18. So the last decimal place is 5. This is the 4 most common situation that we can get with this one. So I instructed you to go through all of them. So I hope that you guys will crack their score table.